Hey, so in the last video we looked at the basic functions, which are the building blocks, if you will, of the primitive recursive functions. In this video we're going to take a look at composition, which is more like the cement. It's going to allow us to construct other functions from these basic building blocks, and hopefully they'll be a bit more exciting. Okay, so this is composition. Composition composes an f, which is a function of our choosing, which takes n inputs and gives us a single input in return. Then we also have n other functions. We're going to call them our g functions, which take where each of them takes let's say m inputs and gives us a single one in return. Notice here that we have as many g functions as we do have inputs to f, and that's important because the whole premise of composition, what composition does, is we're going to give a single input of size m, so we're going to have x1 up to m, right? And we're going to send that same input to all of our g's. Let's pretend there's some g's here. And we're going to send that same input to all of our g's, and they're each going to send an output to f. And because we have n g's, then we have n inputs to f, and that's all we need. So f can now give us an output. And that's the whole premise of composition. And the way we write this out is to say f composed with our g's here, so g1, etc., up to gn. And that's a function from, so what's it doing? It's taking an input of size m and it's giving us a single output. So this is a function from m inputs to a single output. To write out what happens when we give this an input, let's do that quickly. So f composed with g1 up to gn of x is equal to, so what's this going to be equal to? So we're giving, we should give this x1 up to xm. So what's this going to be equal to? Well, all the g's are getting the same input, that's this m long vector, and each of them are going into their respective inputs to f. So what this is actually going to be is f of, first of all it's going to get g1, so g1 of x1 up to xm, and then it's going to get g2, etc., and finally it's going to get gn of that same input, x1 up to xm. Cool. So let's take a look at some examples of composition. So we'll start with a simple example, which is going to use some of our primitive recursive basic functions. And so what we want to do is define the function 1 of x just to be the constant 1. And how can we do that with the functions that we have, which is the 0 function and the successor function? As a reminder, the 0 function takes an x and always returns 0. The successor function takes an x and returns x plus 1. So with a little thought, we can see that 1 of x is actually equal to the successor of 0, which is equal to the successor of course, 0 of x, because 0 of x always returns 0. So how do we express this as a composition? Well, what we want to do is we take this outer thing here, the successor function, and I want to compose that with what's on the inside. So the successor function only takes one input, so we're looking for one g function, and that g function is going to be 0 here. And that's us done. That is our one function. So let's verify this again, just using the definition that we had before. Successor composed with if we give it an input, what's going to happen is we're going to do successor of 0 of x, and of course that is equal to successor of 0, which is of course equal to 1. So we got it right. So we have defined our one function in terms of our basic functions and composition, which is really cool. So let's look at another example, a bit more involved this time. So these are not part of our basic functions, but let's say that we have been given these functions. So let's say for is a constant function which is going to take an input and always output 4. And add is a function which we give it 2 arguments, and it's going to give us x plus y in return. Okay, and we're trying to implement the function +4 of x. Hang on, let's redo that x. Come on. And that's going to be x plus 4. So clearly we can do something like +4 of x is equal to add of x and 4. Now, okay, so it looks like add is going to end up being our f function here. So let's draw out the composition diagram and see what this looks like. So we have add here, and add takes 2 arguments, of course. So we need 2 g functions to do that. And the result, our +4 function, takes a single argument. So we're going to have a single argument going to 2 g functions. We'll call them g1 and g2. And they're going to output their outputs to add. Now we want g1, we look over here, we want g1 to be x. Sorry, the output when we input x to g1 should be x. And the output when we input x to g2 should be a constant 4. So g1 of x equals x, and g2 of x equals 4. So we know what this function is, right? This is our identity projection that we've seen before. Proj 1, 1, so it takes a single element, returns the first element. That's just the identity function. g2, we've seen this before as well. In fact, it's right here. It's just 4, our constant 4 function. So what we're left with is to express this as a composition. I encourage you to pause the video and see if you can write this out yourself. And so let's do this now. So +4 is add composed with proj 1, 1 and our constant 4 function. Okay, let's look at one last example here. Let's say we are given this add function again, which we feed it an x and y, and it gives us x plus y. And we want to define a function add first and third, which is going to take 3 arguments, and it's going to return to us x1 plus x3. So this is pretty similar to add, but it's not quite add, and I claim that we can do this by composition. So pause the video here and see if you can write down the expression of this function as a composition. Okay, so let's look at what we've got. We've already got the add function, and clearly this is equal to add of x1 and x3. So the composition of this is, it looks like add is going to be our f function, add, and add takes 2 arguments, so we're going to have 2 g functions, and the input is 3 arguments, so we're going to have x1, x2, x3 going into our 2 g functions, and we'll call them g1 and g2. And g1 we want to return x1, right? And g2 we want to return x3. So g1 of x1, x2, x3, whoopsie, x2, x3 is equal to x1. So we know what this function is. Okay, we know this is our g1 is our projection, which takes 3 arguments and gives us back the first, and g2 takes 3 arguments and gives us x3. Of course, g2 is our projection, which takes 3 arguments, gives us the third. Okay, so now we're there. Now we can say add first and third. Equals, and we can express this as a composition using just add composed with proj 3.1 and proj 3.3. And that is us. We are there. And this idea of kind of ignoring elements and using composition to select which elements to apply a function to ends up being really useful later on.